Okay, here's another example of what a proof might look like if you're given parallel lines and you need to prove something about angles. So this one is considerably different than the other one that we looked at where we have to prove angles congruent. This time I have to prove, notice that two angles are supplementary to each other. So we'll come back to that in a second, but let's go ahead and get our proof set up here. So, of course, starting off with my given. And we know A is parallel to B and C is parallel to D. In the future, we might be given one set of parallel lines, not two sets. So just a heads up for that. But for right now, we know both sets of lines are parallel. So for this proof, I am going to sort of try to work backwards and say that if I want to prove angle 2 and angle 13 are supplementary, that the second to last step in this proof, in other words, the statement that would guarantee that I know angle 2 and angle 13 are supplementary and would lead me to say that would be the equation of the form measure of angle 2 plus measure of angle 13 equals 180 degrees. And I think you can agree with me that if we saw that equation, that we would definitely conclude angle 2 and angle 13 are supplementary, because my definition of supplementary angles tells me that if two angles add up to 180 degrees, they are supplementary. Okay, a lot of times we use our definition the other way to say if angles are supplementary, then they add up to 180 degrees. But remember, definitions are biconditionals and they can go both ways. So here's my thought. The reason that I took the time to write that down is because I'm going to go from that equation and say, okay, I don't know 2 and 13 are supplementary, but let's see what I do know, because here's the problem. 2 and 13 aren't an angle pair. But can we find an angle pair that is supplementary that we do know adds up to 180 degrees? So you got to think back to all your angle pairs. We've got the alternate interiors, alternate exteriors, consecutive interior, and corresponding. Which pair is the supplementary angle pair when lines are parallel? If you said consecutive interior, you're on the right track. So what I'm going to do is I'm going to find a consecutive interior angle pair. And there's actually a couple options here. So I'm just starting with 2, and I'm going to say, okay, I don't like 2 and 13 because those aren't an angle pair, but how about 2 and 5? That's a consecutive interior angle pair. If you're looking at lines C and D, they're both inside. I'm looking at the top half of my picture right now. And they're both inside between the two lines, and they are on the same side of my transversal. So I'm going to state that angle 2 and angle 5 are supplementary. And that's my consecutive interior angle theorem. If you're on your blue sheet, that is number 13 on your blue sheet. Okay, I'm summarizing right now the statement, if lines are parallel, then consecutive interior angles are supplementary. And we were using the fact that C is parallel to D there. So there's my hypothesis, and there's my conclusion, making that true. Okay, so I want to go ahead and get to an equation because I like to work with equations. So I'm going to turn that statement into an equation. And my equation is going to be the measure of angle 2 plus the measure of angle 5 equals 180 degrees. And this should almost just be an automatic step that you do whenever you see a word here. You make an equation, and then you use the definition of that word to support the equation that you wrote. So I know that because they're supplementary. My definition of supplementary angles tells me so. Now, I sort of set myself up here for what I wanted to see happen, and I wanted to see that this angle 2 is still angle 2 down there. That's looking good. And what happened is angle 5 is being replaced with angle 13 there. So how might I be able to replace angle 5 with angle 13? Well, the only way I could do that and keep everything else the same in the whole equation is if I knew that the measure of angle 5 was equal to the measure of angle 13. So go back up to your picture and tell me, do you know that the measure of angle 5 is equal to the measure of angle 13? And if so, how do you know that? So when I'm looking at my picture here, angle 5 and angle 13, I'm recognizing are a corresponding angle pair. And if lines are parallel, and indeed A and B are parallel, that's the pair of lines I'm using, so I'm really using the right half of my picture here. 5 and 13 are a corresponding angle pair and therefore congruent. So if A is parallel to B, then angle 5 is congruent to angle 13 by my corresponding angle postulate. Technically, this is like one of those little minor details. I should state that the measure of angle 5 is equal to, sorry, let's try to make that legible. The measure of angle 5 is equal to the measure of angle 13, because before I substitute, I should know that their measures are equal. I know it's almost the same thing when I say congruent, but not quite. So I am using my definition of congruent angles in there. And then you probably already figured out what we did in step 16 just by the way I said it. We replaced or substituted, so that's my substitution property. Just a quick note, that one could not be transitive because I'm not replacing the entire side of the equation. I'm only replacing that one part, angle 5, with angle 13. So that's it. Strictly substitution, not transitive. And that allows me to conclude step 7 by my definition of supplementary angles there, because I knew the two angles were equal to 180 degrees, and therefore I'm concluding that they're supplementary. If you skip step 5, not a big deal. That's kind of like one of those really picky details that we should be saying, but not a huge deal. Otherwise, the flow of the proof should be pretty good. That's mainly what I'm looking for, is that you can get the substitution in there and give me some equations. So if you got that, then the next one right below that would be a really good one to try and see if you can do that one on your own.